Hello everyone. Okay, let's get started. So 3 over 11 plus 8 over 11, you can easily figure out is 11 over 11, which is equal to 1. But let's work out the second part of the problem, see where we get. Let's write out the exact decimal for 3 over 11, which means that we're just going to treat that like division. So we will say 3 divided by 11, and I have a suspicion we're going to get into decimal places, so I'll just put a bunch of zeros down and see how many we need later. Okay, so how many times does 11 go into 3? 0 times. 11 times 0 is a 0. Subtract that, we get 3, and I'll take down the next 0, and I will copy over this decimal point up here. How many times does 11 go into 30? Twice. 2 times 11 gives us 22. And 30 minus 22 is 8. I'll take down a 0. 11 goes into 87 times. So 7 times 11 is 77. And subtracting 77 from 80 gives 3. I'll take down another 0. 11 goes into 3. Oh, only 2 times. And looks like things are already repeating. 2 times 11 is 22. Subtracting, we are back to 8. And we will get another 7 here. And you'll see that if you keep going, you'll just keep getting 2, 7, 2, 7, 2, 7, and so on. So how do we represent this fraction? We are going to write 0.27 with a bar over the 27 to show that that is repeating forever. Okay, so that's good. We got that. Now let us find the decimal for 8 over 11. So we're going to do the same thing. So I will divide 8 by 11. I'll add a bunch of decimal zeros. How many times does 11 go into 8? 0 times. 0 times 11 is 0. And we get 8. Take down another 0. I'll copy this decimal point over. 11 goes into 8 7 times. And 7 times 11 is 77. The difference is 3, and 11 goes into, I'll take down a 0. 11 goes into 32 times. 2 times 11 is 22. Oops, that lands me back at 8. Taking down a 0, 80. 11 goes into 87 times, and once again we are repeating. So this time 7, 2, 7, 2, 7, 2, 7, 2 is repeating, which we will represent by writing 0.72 with a bar over the 72 to show that it is repeating. So we've arrived at the last part of the question. We are going to see what happens when we have the decimal versions of 3 over 11 and 8 over 11. So when I added 3 over 11 to 8 over 11, I got 11 over 11, which is equal to 1. So what happens if I add 0.27 repeating to 0.72 repeating? Well, I get 0.2 plus 7 is 9, and 7 plus 2 is 9, 9 repeating, which I guess I could also write as 0.9 repeating. And of course, I can check that that's actually what's happening here. 0 plus 0 is 0. 2 plus 7 is 9. 7 plus 2 is 9. 2 plus 7 is 9. 7 plus 2 is 9. And that's going to go on forever. So it is actually the answer. 0.9 repeating is the answer. So you're probably asking yourself, how come 0.9 repeating is the answer when you add the decimal versions together, but 1 is the answer when you add the fractions together. Well, the answer is that 0.9 repeating is actually equal to 1. And I know that sounds really weird, but think about it this way. And I'm going to attach a link so that you can see a proper proof if you want to. But the way that I try to think about it is, say you have 0.9999999, and that's just repeating forever. So now ask yourself, what do I have to add in order to make this 1? Well, if I want to get a 10 or a 1 somewhere, I'm going to have to add a 1 to a 9 in order to get in order to turn it into a 0 and then get a 1 before it. So let's just see what happens if I add 0.1. Okay, well, I get 1.0, but then I still have all these other 9s behind here. That's not going to work. So scratch that. What if I add 0.0001? Okay, well now I have 1.0000, but then again I have all these 9s repeating forever behind at some point in the decimals. The question is, how far back in the decimals do I have to go and add a 1 so that I don't have any 9s left over at the end when I finally get my 1.000 something? And the answer is I can't. No matter how far back I go to try and add a 1, the 9s are going on infinitely. So really the only choice that we are left with is that 0.9 repeating is just equal to 1. And this is how I like to explain it to myself, because I think that kind of clarifies it for me. But I do recommend that you take a look at the proof and explanation that is posted underneath the video.